welcome back to Explore VLSI. This is day 47 of 100 days series. Today we are stepping into randomization in SystemVerilog. In the last video we have seen abstract class, parameterized class, extend keyword, and what is scope resolution operator and how we will be utilizing it. Now we need to understand a very important constructs, that is $random, $urandom, $urandom range, and a very important feature of SystemVerilog to randomize the data, that is randomize, how to utilize that randomize function with constraints, and what is pre-randomize and post-randomize functions we will be writing in the test bench. So let's get in. What is randomization and why it is so important? Randomization in SystemVerilog is very important feature. We can't write the data like as we do in the Verilog test bench manually. Why? Because as designs becomes complex, we need to randomize the data and we need to touch upon all the corner cases of the DUT functionality. So the very first point is verification is not just about checking the expected cases. You might have expected some cases of the functionality in DUT, but there are other cases need to be checked which are all not so important or which they are very important. We need to check all the small cases as well. That's why randomization is very much important. Otherwise, real hardware fails in unexpected corner scenarios, right? And manual test writing is very slow and limited. Manually, if you want to provide all the values through forcing, it is very difficult to touch upon all the different cases of the DUT. So, but with randomization, we can generate thousands of meaningful test scenarios with very little effort. And again, randomization removes the human bias as well. As a human, engineers usually test what they expect will happen. But randomization tests will go through all the different corners of the DUT and all the different cases, conditions, everything need to be tested through randomization. We are able to achieve all the different cases where human can't do that. That's why human bias can be removed by using randomization. It drives the functional coverage. It helping us to explore the complete input space and reach the coverage goals faster. Coverage in the sense, we need to go through all the different cases, functionalities of the DUT without missing any one. If any one of the functionality is missed, our coverage is not 100%. It is like we are covering all the different cases of the DUT or not. That is what the coverage result is. If it is 80%, let's say, another 20% need to be covered. That can be covered if we randomize the things more and if we generate all the different cases of possible inputs. So coverage goals can be achieved faster, more systematically using randomization. And random tests stress the design. Yes, pushing the DUT through unusual cases, extreme situations, and complex situations as well to ensure the robustness before the tape out. If once the tape out is done, you can't test the DUT through the simulation again. Now we need to understand the very first thing in randomization, that is $random construct. This $random is a old Verilog random number generator. It returns 32-bit signed integer value. The range is from this value to this value. It generates a signed value always because the return type of a $random is a signed integer itself. You can see I have utilized that here in this example. Module Verilog randomization initial repeat 4 times. I am just repeating this display statement 4 times. Here is my random construct $random. Here I am not utilizing any of the variables to randomize. Just I can do $random so that it will generate a 32-bit signed integer, displaying that number over here as decimal. You can see again I am repeating that 4 times with a seed value here. What this $random do? It will just generate the 32-bit signed integer. But if you specify any number over here in a braces, this specifies a particular number will be generated whenever you call $random. Let's say this will be called as random seed. Seed is 5. It generates only these numbers. You can see here this display statement is executing 4 times with $random. It is generating a positive number here. Then it is generating 3 negative numbers as well. So this will generate signed integer values. Then the next 4 iterations, this repeat statement displaying 4 values again through $random. But we are providing a specific value here. This will be called as seed. It is producing minus this value 4 times. Means you can stick that randomization to a particular set of values by providing the seed. That is what we need to understand. Then we have $urandom as well. The difference between $random and $urandom is that this U specified that it is unsigned integer generator. Urandom is a unsigned random value generator. Here also it will generate 32-bit unsigned integers. The range is starting from 0 here. No negative values are going to be generated. There is an improved version of that is $urandom_range. You can provide the minimum and maximum value of the value what you are supposed to generate. Let us understand all these. Here I have initial repeat, the same statement for display here, $urandom with %d, and I am providing $urandom construct here. This will generate 5 random values. You can observe the first 5 random values here in the output. All those are positive values. Then again I am generating 5 values with a seed here. If you provide only one number, this is a seed. If you provide with urandom range with 2 number, this specifies the first one is a minimum number need to be generated and the second one is the maximum number need to be generated. This is the range we are providing here. So this 10 is a seed. This seed provides a proper exact constant value as a random value. You can see all the 5 iterations will be generating this value continuously, right? For 10, if you change it to 5, another set of value are going to be generated. Then I have a third initial statement with repeat 5 times. This is $urandom range. This range can be specified only with urandom. $random doesn't have this facility. $urandom range 2,11. You can observe the next last 5 set of values generated. It covers 2 and 11 as well, and only in between 2 and 11 the values will be 5, 11, 2, 3, 9, all are in between 2 and 11. Then we have randomize function itself. This randomize function will be a advanced construct, we can say. We can randomize a particular variable and also we can randomize a complete set of object. You can see here module SV randomize example, reg 7 down to 0a. This is a register A it can able to store 8-bit of data. So initial begin if randomize A. This randomize of A is the construct we are utilizing to randomize the value for A. If we are utilizing this internally in a if statement, this will be a condition. Means this randomize function, it will randomize the value for that A and also it will generate value 1 as a return type. If it returns 1, it means what? This condition is true. And also it will generate a value for A. Begin displaying that value what A got. A got 110. If this randomization failed, we will be having an else part here, display randomization failed. Okay. Suppose if you are providing a variable which can't be randomized, then it will throw an error. So randomize will be having a return type that is a single bit, whether it is 1 or 0. And also it will provide a randomized value to the variable what we have provided here, right? So we got 110 over here, which for A. Then we have a randomize function which can be randomize a complete class object that we need to understand. To randomize the class object, we need to specify the properties of the class with a rand keyword. You can see here we have a class packet and end class. Internally we have 2 properties, data members, that is address and data. This address is 3 down to 0 bit type, data is 2 down to 0 bit type again. These 2 are represented with rand types. Means whenever we are going to create the packet class handle as packet P here and we are creating an object for that, then the complete packet will be consisting of address and data will be randomized. Means this address and data both are going to be participate in the randomization. Suppose if you skip writing rand for address, if you have written only rand for data, then address will not be randomized, only data will be randomized. That's why what are all the data members need to be randomized, you need to specify it as rand. And here we have a function to display that value. Now in a module TB, in initial begin, we have a handle for the packet class as P, and this new function will be a constructor. It will be used to create an object and assigning the default values for address and data. And as soon as we create, we will be calling the repeat function with 10 times. Repeat 10 means 10 times statements what we have written under begin end will be executed. P.randomize. What does it mean? P is a object class type. Dot randomize means it will randomize the content or the data members present inside a class with rand keyword. This will randomize 10 times. You can observe here address 3, data 7, address 6, data 7. Similarly, all the different values are going to be generated for address and data. Okay, since we are using rand here, we need to observe there might be a repetition of the same value before it completes all the possible values. You can see since these two are represented as rand, data is 7 here, again 7 is generated, again 7 is generated, again 7 is generated, right? This data is 2 down to 0, means 3-bit variable. 3-bit variable in the sense it can take 0 to 7 value. But before completing all those, 7 7 is repeated, 5 5 is repeated. This is what rand type will do. If you want to generate one cycle of values starting from 0 to 7, then only the next value need to be repeated. Then you need to use rand C here. That's why there are two types of declaring the variables, with keyword rand, or you can declare with rand C. If you need a cyclic kind of values, means for a data if you take, it will start with some other value, something like 7, and until all other 0, 1, 2, 3, 4, 5, 6 completes, 7 will not come again. That is what rand C is, that we need to understand here in the next example. That is rand C. When we use rand C, you want all values to appear once before any repetition happens. Okay. The only change I made in this example is that I am using rand C in place of rand. So you can observe in a data 2, then 1, 0, 5, 6, 4, 3, 7. Here it completes all possible 8 values. Then again 3 repeated, right? 0 is there, 1 is there, 2, 3, 4, 5 is there, 6 is there, 7 is there here. All 8 values are completed for data. Then only again 3, 7, next 8 different set of values are going to be generated. Then it will repeat, right? That is how rand C works. This is a very important interview question. You will get a question like, what is the difference between rand and rand C? You need to say rand C when we are going to use means if you want all values to appear only once before any value repeats. That is rand C. Then a very important feature with randomize, that is constraint. You can put a constraint so that the randomization will follow that rule and it will randomize the value. It is something like, if you look at the example, I have used the same example here again, address and data, and I have an inline constraint here with p.randomize. You can observe p.randomize within the flower braces I have written a rule for the randomizer. p.data should generate inside 1:5, means it should generate the values only between 1 and 5. It should not generate 0, it should not generate 6, it should not generate 7. I am constraining my randomization to only these values. This is a type of constraint. We call it as inline constraint. We are writing the constraint or the rule for the randomizer in a same line when we are calling the randomize function. That will be called as inline constraint. Okay. So here if you look at the value of data through this display, when we call p.display, data is 2, 4, 5, 3, 1, 4, 2, 3, 5, 1. You are not seeing 7. We are not seeing 7, 6 and 0. Why? Because we constrained the data to generate in between only 1 and 5. This is how we can utilize the constraint to give a rule for the randomizer so that it will follow that. Okay. Then we have another feature called pre-randomize and post-randomize functions. In a class packet with these data members and a constraint, we can write a function as well, so that with randomization, it will also look at what you have written in a pre-randomize and post-randomize functions. Means in a module, we will be calling p.randomize. What this should do? It will look at which are all the variables in a class you have defined it as rand, and it will just randomize that. If you put an inline constraint, what it will do at the time of randomization, it will look at what the rule you have made. But you can write a pre-randomize and post-randomize functions. This pre-randomize function will execute before the randomization. If you want to set anything before the randomization, you can put it over here. You can observe I have a display called inside pre-randomize. When it is executed, pre-randomize call is happening here. You can observe before the randomization call. Then inside pre-randomize, it went to pre-randomize function and it is displaying this about to randomize. The current value of address and data I need to know. That's why I am printing here. Then after that, randomization will happen. Randomization will generate its value, and then inside post randomize, you can observe there is a function called post randomize. It will come into this function and it will execute. Inside post randomize, after the randomization completes, data and address what it generates is 24 and 3. The final values I am printing through a display function again by calling p.display. This is also providing 24 and 3. So here the flow is that whenever we come to p.randomize, the simulator will look for whether we have a pre-randomized function written. There is no pre-randomized function call here. Have we written pre-randomized function call? No. Randomize function directly look at the pre-randomized function definition inside this class object P. If it is there, then it will execute this. Then it will look at the constraint. It will execute this constraint part. Data should be less than 10. This is the constraint block we have written inside a packet. Previously we have seen the inline constraint. This is a constraint block. We can write a constraint block like this other than writing the inline constraint. Let us understand all the different types of constraints in the next subsequent sessions. So this is the important introduction to start the constraint. Okay. Here we are starting the constraint as data less than 10. So we are getting data is equal to 3. And first pre-randomize will execute it. Then the constraint is executed. Then it randomizes the things. Then post-randomize is executed. Then it is displaying the thing. This is how the flow of randomization will be. This is also an interview question. When actually this pre-randomize, post-randomize will be executed. When this constraint will be executed. When you call the randomize function. Okay. This is all about the randomization in SystemVerilog. We have seen from simple $urandom and random to a randomize function with pre-randomize and post-randomize. Okay. This is all about the randomization. In the next video, let us understand how constraints works and which are all the different types of constraints. That is very, very important for the knowledge point of view and also for the interview. Okay. Thank you.